we will explore how to build RESTful APIs, which are essential for modern web development. This module focuses on designing, developing, and securing powerful web services for your applications. Let's begin by gaining a fundamental understanding of what APIs truly are and how they function. APIs establish the rules for seamless software communication and efficient data exchange between systems. At its core, an API is defined as an application programming interface, a crucial communication tool. Essentially, an API is a set of defined rules and protocols that govern how software components interact. This framework allows diverse software applications to communicate effectively and share information with each other. Ultimately, APIs enable robust system integration and facilitate efficient, structured data sharing across platforms. Now, let's examine some of the key characteristics that define effective and powerful APIs. APIs provide a structured and clear interface, ensuring predictable and reliable interactions between systems. They are platform agnostic, meaning they can function seamlessly across various technologies and operating systems. For data exchange, APIs commonly utilize either JSON or XML formats, ensuring structured communication. We will now delve into the core principles that govern RESTful APIs, a popular architectural style. REST is an architectural style, primarily designed for building robust and scalable networked applications. A fundamental principle of REST is that it is stateless, which is very important to remember. This means each API call is entirely independent and the server retains no client context. REST also promotes a client-server architecture, separating concerns between the two components. The client and server are decoupled, allowing them to evolve and be updated independently without affecting each other. Another key principle is the uniform interface, which provides consistency across the entire API. This means consistent API conventions are used, making it easier for developers to understand and interact. REST APIs are also designed to be cacheable, optimizing for better performance and efficiency. Server responses can be cached by clients, which helps to significantly improve overall application performance. The architecture supports a layered system, allowing for flexible and scalable deployment options. This design allows intermediaries like proxies or load balancers to be used without altering the API's behavior. Let's now explore the essential terms you will encounter when working with RESTful APIs. These terms are the fundamental building blocks for understanding and communicating effectively within RESTful systems. First, we have the concept of a resource, which is central to RESTful design. A resource simply represents any entity or object within your system, like a user or a product. Next, we have representation, which defines how a resource's data is structured for transfer. Data is exchanged between the client and server using these representations, typically JSON or XML. An endpoint refers to the specific network location where API calls are made. It is the URL that uniquely identifies a specific resource or an action to be performed. Finally, HTTP methods are crucial for defining the type of action to be taken. These standard HTTP methods specify what operations clients can perform on the identified resources. We will now examine the common HTTP operations and their corresponding responses in RESTful APIs. This section will explain how clients interact with servers and interpret the feedback received. The GET method is used to read or retrieve data from the server without making any changes. Its primary purpose is to retrieve information or resources that already exist on the server. For instance, a GET request to /users would fetch a list of all available user resources. A 200 OK status indicates a successful GET request, meaning the data was retrieved correctly. The POST method is used to create new data or submit information to the server. It's typically used when you want to add a new resource to the collection on the server. For example, a POST request to /users would create a new user entry on the server. A 201 created status confirms that a new resource has been successfully created on the server. The PUT method is used to update an existing resource or completely replace it with new data. You would use this when you want to modify an existing resource, providing its complete new state. For instance, A put request to /user/1 would update the details for user with ID 1. A 400 bad request indicates a client-side error, meaning the server could not process the request. The delete method is straightforward, used to remove a specific resource from the server. It's intended for permanent removal of resources that are no longer needed or desired. For example, a delete request to /users/1 would remove the user with ID 1. A 404 not found status means the requested resource could not be located on the server. We will now walk through setting up your PHP environment, a crucial step for API development. This involves preparing your system to efficiently develop and run RESTful APIs with PHP. First, you'll need to install a server stack, which includes a web server and PHP runtime. You can choose to install XAMPP, WAMP, or LAMP depending on your operating system. Next, it's essential to set up your database, which will store all your API's data. This involves creating and configuring a MySQL database to manage your application's persistent storage. Then, you should create a dedicated API directory to organize all your project files. This means setting up a specific folder where all your API-related PHP files will reside. Finally, you'll need to define your database table schema for storing user information. Specifically, create a users table with columns for ID, name, and email to store user data. Now, let's establish a robust database connection within your PHP application. This section focuses on establishing a PDO connection to your MySQL database, a best practice. We'll create a file named db.php to encapsulate our database connection logic. The PDO object handles the database connection and is configured to throw exceptions upon error. This code snippet initializes the PDO connection, setting up the host, database name, username, and password. Next, we'll learn how to effectively handle incoming HTTP requests within your PHP API. This involves routing API calls to the correct functions based on the request method and endpoint. First, we include the database connection script and set the response header to JSON format. This code requires db.php and sets the content type header to application JSON. Next, we determine which HTTP method was used for the incoming request. We capture the request method from the server superglobal and store it in a variable. Then, we implement a switch statement to handle different request types like GET or POST. This switch block routes execution to the appropriate logic based on the identified request method. Finally, we provide a default response for any HTTP methods that are not supported. This code sends a 405 status code and a JSON error message if an unsupported method is used. Now, let's explore how to consume APIs using JavaScript's fetch API from the front end. We'll cover how to make both GET and POST requests from your front-end application to interact with APIs. First, let's look at how to perform a GET request to retrieve data using the fetch API. The fetch function retrieves data and returns a promise that eventually resolves to a response object. This code demonstrates fetching users from a placeholder. API handling both successful responses and potential errors. Next, we'll examine how to send data to an API using a POST request with the fetch function. The fetch function can submit data, with headers specifying content type and the body containing JSON stringified data. This code illustrates sending user data to create a new entry, managing the response, and any potential errors. Securing your APIs is paramount, and we'll now cover authentication methods to protect your data. We will explore how to protect data using JWT, which stands for JSON Web Token, and OAuth 2.0. First, let's discuss JSON Web Token, often referred to simply as JWT, for API authentication. JWT is a compact, URL-safe token format used for securely transmitting information between parties. The server generates this token, and the client then includes it in subsequent requests for verification. The server verifies the JWT's authenticity before granting access to protected resources, ensuring security. Next, we'll examine OAuth 2.0, Another widely used protocol for secure API access, OAuth 2.0, is an open standard designed for access delegation, enabling secure third-party integrations. It allows third-party applications to access resources on behalf of a user without requiring their credentials. This protocol primarily uses authorization tokens and access tokens to manage and grant permissions securely. Let's summarize the key takeaways from this module, reinforcing the essential concepts we've covered. These are the essential concepts you need to remember for effectively building powerful, RESTful APIs. Remember, APIs are fundamental, enabling various applications to communicate and seamlessly share data. RESTful APIs are characterized by being stateless, highly scalable, and generally straightforward to implement and use. HTTP methods like GET, POST, PUT, and DELETE are used to perform CRUD operations on resources. PHP offers robust tools and frameworks for developing powerful and efficient RESTful APIs. The fetch, API, and AJAX are primary methods for consuming APIs within front-end applications. JWT and OAuth 2.0 are crucial authentication mechanisms for ensuring strong API security.